A lab technician inspects each solar cell, looking for any defects in the cell, such as cracks, chips, or malformations. At this step, the individual solar cells are very delicate and are prone to breakage. Once inspected, the cells have two filaments soldered onto the cell. These will be used later to connect the solar cells together. The technician will now place cells on a jig that will align the cells properly beside one another and provide the proper spacing. After the cells are laid out, the technician will begin soldering the series together. In this particular panel, 10 cells are used to create one series. When all the soldering is complete, technicians will ready a glass panel for each solar cell series. They begin by cleaning off the tempered glass surface, making sure it's free of any unwanted material. An EVA plastic material, which helps bind the elements together, is placed on the panel, followed by a spacing guide. Now the technician can lay each series of solar cells onto the surface with the correct spacing and alignment. Adhesive tape is used to keep the alignment. A final visual check is performed, and each end of the series is prepared for soldering. Once the spacing is lined and verified again, the series can then be soldered together. The guides are now removed and the final layer of EVA plastic can then be placed on the top of the cells, and a piece of adhesive tape is used to secure it together temporarily. An area where it can be inspected. Technicians lay the panel on a holder front side down and illuminate to check for deficiencies. Once completed, the panel is connected to a machine that is attached to a computer to check the efficiency of the panel. The technicians want to confirm that the soldering process was successful. Now the panel elements are ready to be sealed together. The panels are placed on a lamination machine that heats the panels to approximately 150 degrees Celsius, which will bind the material together. This process takes about 30 minutes to complete, and when completed, each panel is removed and allowed to cool for 15 minutes. While the panels are allowed to cool, the workers prepare the frame of the solar panel in a framing machine. Before framing, a technician will remove excess material from the solar panel caused by the lamination before placing it in the framing machine. The framing machine clamps down and adds the proper amount of pressure to attach the panel to the frame together in one simple step. Now workers will add a junction box in the rear of the panel. This is where the panel will hook up to the microinverter. Leads are connected and a generous amount of silicone is used to keep the junction box free of moisture. The technician places the top plate on, completing the process. The panels are stacked and wait for testing. Finally, the solar panel is brought back into the lab for one final test. The panel is again attached to the machine that will measure the efficiency of the panel with a flash of light. Once the panel has passed the tests, it's ready to produce green energy for our planet and our future.